How's it going, guys? Today a little bit different, not a tool. So soon it will be a tool, but for now I will just do a tutorial on how to actually do this. This will probably be part of Easy Peel at some point, but for now let's just see how it's done without any help of a tool, basically. So what we have here is we have like a few layers that are peeling away. I got the inspiration of a video I just randomly stumbled over on Vimeo, and I wondered like how would I recreate this one, and I started tinkering around a little bit, and I will show you how to do it yourself as well now. So we will start with only one layer, so I will just disconnect all these layers here on the side, and I won't build it from scratch, but we will go through it one by one, just so you can see it. So we start with like a very basic grid, just literally 10 by 10 grid, and you can reduce the rows and columns to 2, so you don't have like any polygons in between, just these lines. Let me actually show the polygons like so, and you only need 2 by 2, and then we want to cut them apart. You can obviously build this differently. You could also first only do like a strip and then copy the strip multiple times, or even do like different shapes, but in this case I will just do like straight cuts. So we create a line on the other hand that should be oops, I'm showing me the line settings, should be the same size or probably even like a little bit bigger than our grid, and then we scatter some points on top of that. I set the relaxation to 1 because that makes them to be a little bit relaxed, but still gives like a random offset in a way. If you keep it at like, I think 10 is the default, they are way too equally spaced. So this just gives it a bit more randomness. And then you literally just copy a grid that is like vertical on it, and you use a boolean with set to surface. Make sure you have it set to surface. The default is solid and it just will error out and nothing works. So set A and B to surface, which is just A and B, the inputs, and then set the operation to shatter, so you only cut it but you keep all the pieces. All right, so now we have cut it, and we can use like a connectivity sop to get a class attribute and understand that these are all different pieces. All right, so yeah, once you put down the for each, you just put a remesh inside. I set it to 0.1. You can set it to the value you need depending how big your input geometry is. This is fine, still simulates quite fast, but the resolution is enough to make it look good. And then what we want to do is for each of these pieces, sorry, I was displaying a little bit lower, so don't worry about the offset. We will talk about that a little bit later. But in here we have a little vex expression that just finds the edge points basically, so, and puts them in a group called edge pin. So if I put down a color node here, just so you can see what I'm talking about, make it red and put it on edge pin and height the class attribute. So you can see we only selecting the points that basically touch this bounding box. All right, from there we just give it UVs. That's just important if you want to do some shading later. As you saw in the beginning, I put a wood texture on it, nothing too fancy yet. That will probably come in some later parts. I want to make it look as nice, if not nicer, than the reference I found. And that's basically your input geometry. Later you could do this for multiple layers and just offset them a little bit to have like multiple layers peel away, and then just change the, like add a little bit of a different global seed on the line to have different cutting patterns basically. From there you want to merge them. We keep it as one stream for now, and you want to use an assemble node to just pack them to points. So each of these strips now is only represented as a point. So if I show the points, you can see they all got a point in the center, and they are essentially pack primitives now. So make sure you use the create pack primitives here. Then I just use an attribute noise. I set it to P, Default is CD for color. I just set it to P, and I just offset them on X. So I just unticked these by default they're on, and you can see that's not really what we want. We only want to slightly offset them this way, because it looks a bit cooler if the seam is not exactly in the middle all the time, and it's changing up a little bit. Once we curl this thing back into a circle, like, they will match up perfectly, no matter like how they are offset on the x-axis. So then I just colored it again to have like a random color here. Not even sure why I did this here. That's not really necessary, but it's nice to have. It's a bit nicer to look at. Unpacking it again, just to have like all my attributes and files back, and my UVs back and whatnot. And then again, using a connectivity, probably, yeah, we still have the class, so technically you don't have to do this again, but it doesn't really matter, it's just overriding it anyways. So I just put down like a for each by connectivity again, and then we start bending. So this is the stream we're working with, and this is basically exactly the same stream, but I disabled the bending. So let's have a look at what I did here. So they both are for each by connectivity, and this one first goes for each strip and centers it again, so we don't have the offset, because then it's just a bit easier to do the bending. You could do it with the offset as well, you could probably calculate where it is, but this just makes it way easier. So what we do here then, we just bend it by a very strong angle. So you can see this is like what we're doing, we're just bending it in this direction, and I think I've had it set to 800. This number, obviously this is like more bends than you need, but you want quite a strong force later in the simulation, so you might want to even increase this number if it's not really doing what you want. And this is just like a standard band. If I display it here and put it back to 0, you can see I'm starting sort of not really fully in the center, because I don't want them to curl to the center, so I offset the origin a little bit to the side. Capture direction is an X, and the other one is in -X, and the capture length is 5. So just make sure it goes like over the piece, basically. And then again, curl it up to like 800 in my case, and then we do the same for the other side. So this is the same, 800. Capture origin is in minus now, and the direction is also in minus, obviously, because we want to curl from the other direction. And again, capture length 5, just to cover the entire strip. Then we do a match size again and offset it to its original position. This only works because in this match size here, very important, we stash the X form, which means the offset that we did here from, let me hide this other thing, the offset from here to the center, we want to stash this, we can stash this information in our attributes, and then on the second match size we can restore that, so it moves back to its original offset position. So if we look at this, they're all offset again like we put them in. So if I disable this one, you can see they're all in the center now, and that's not really what we want. We want them in their original positions like they came in here. Okay, cool, so they are bent now. I actually called it blend. Should be blend. And yeah, just put a null here. Good to organize this because we want to recall it in the simulation down here, and then just copy this entire thing like so with Alt, and just well, you know what I mean, like this, and then you just disable the bends, and you have what we have here. Technically you could even not do this at all and just pipe it straight through. But I think it's like, for me, just visually, it's nice to have it there, and see that this is basically the same as the other stream, and I'm not doing anything like extra here, sort of. This is just visual, but technically you wouldn't even need this, so you could delete this entire part here, because we don't change this geometry. We match size it and put it back to its position. So yeah, So you can see this, and this is exactly the same. From there, what we want to do is create or use the group, the edge pin that we created in the beginning, and make it grow towards the inside in this case, because it starts from the outside, and that's what we want to do. So again, here another connectivity for each connectivity sub. Again, we probably would need this class here, but I always like to keep it, because as I said, it's overriding it anyways. So as long as we don't need consistency of this, it should be fine. And actually it looks like it might even keep the same class anyways. But again, it's a good visual representation that this for each is a connectivity for each. I mean, yes, you can check it in the settings. Obviously, like this is set to class, the piece attribute, like by piece or points, primitive, and we use the class attribute on the primitive. But it's nice to have this anyways, just to see what you're doing. So in here, we use a group expand, and we use this group expand with an expression. And what this is doing, let me, I have a color node here that's actually calling this group. So let me display it here. So what this is doing, you can see if I hide the other color attribute, you can see this now grows like from the outside to the inside. And as we offset this strips a little bit, it also is a bit random automatically, which is quite nice to have. And we're just using this group later to basically unpin these points so they get dragged back to the spent position. So this is quite important. The way this works is you need in the for each. So if you do like a for each connected pieces, you can create a meta import, and you can do this when clicking on this node, and you can create a meta input node. And what this is literally doing is you can grab iteration, num iterations value, and I value from this. So you can grab detail attributes from this. So this basically counts each iteration. Which is nice to have, because that gives us even more offset, like you can see here. If we don't do this, so if I let me copy this super quick so I'm not destroying too much. So if I remove the iteration here, like so, you can see they are already a little bit offset, but not as much as if we had the iteration in here. So this expression, what this expression is doing, is using frame, and I'm doing in these columns here, I'm doing frame minus $f start, because my sequence starts from 1001. If you start from 1, you could just do at frame, and then I do -2 just to have it basically have no group in the beginning whatsoever, so it starts from fully 0. And then I just do a minus, and this is calling the iteration. So this is calling detail -1 iteration 0. And it's calling it from the spare input, and to create the spare input, again, let me demonstrate this one. You create the meta input node, and then on the group expand node, you can do this on any node, by the way, but you can just do add spare input, always searching for this, and you can just drag this one in here, and then it's a bit easier to call it. You could also call it directly from this node. You don't need to create the spare input, but it just makes it a little bit easier, because you can then just do -1 iteration on the spare input 0. And this is the attribute, that we're calling, which is the iteration. So basically we have, how many do we have here? We have 10 iterations. So for each it's doing like -0, -1, -2, and so on. So they all get a little bit offset, and in the end we have this nice thing here. And again, from there we do an out pin. Let me remove this again. And this is what we're going to use in the Vellum solver as well. So to use it in the Vellum solver, let me actually not do the spiral thingy for now. So we keep it flat, so it's a bit easier to understand. And we just need to create a Vellum cloth. So you just put down literally a standard Vellum cloth. Vellum can type Vellum configure cloth. And from there I just changed a few settings, which is the dampening ratio, and I set the bend stiffness to 1. That just makes it a bit more active towards the rest blend that we're using in the Vellum solver. You can leave it at standard as well, but you will see you have a hard time actually making them curl. So this just makes it behave a bit more accurately if you want. All right, from there we want to pin to target, and we basically pinning everything. So you just put down a Vellum constraint, not like a standard one. This one here, Vellum constraint, and you can set it to pin to target. And from there you just don't put anything in here, just set it to stopped. So they are frozen once they come in the simulation, so they don't do anything. And then in the simulation, let me go in here. You can see I put down a standard Vellum solver, set the substeps to 4. You can keep it on 1 just to test it and make it work a little bit quicker. But it's not going to curl as nicely as well. Because there's like quite a lot of like distance and force that it needs to calculate correctly. So it's a bit nicer if you set it to a higher number, like 6 might be even better than 4, but I kept it at 4. That was totally fine in this case. You can sort of counteract with the constrained iterations. 40 is fine in this case, so it's like times 10 of whatever you're doing here. It's like a good rule of thumb, just to make it a bit quicker again, but honestly it doesn't really matter that much. You can leave it at 100 as well. In there we have 2 things. We have a geometry wrangle, which basically says, so if the endpoint, so the point group that comes in into the stream 0, which is our first connection here, if that is equal to 1, then we set the I at stopped to 0. So remember, we set a stopped value here. Here on the pin to target, we set it to stopped, and that just sets it to I stopped at 1, as you can see here. Then we have our pin group that comes from this side here, and you're wondering, okay, didn't you just say input 1? Yeah. This just means in the geometry wrangle you can override this, or put a different input, and you can see here the input is actually highlighted as well, and you can just say input 1 is SOP, and that points to our pin group here. So we can just load this in as the point numbers are exactly the same as on the Vellum geometry. This perfectly understands and works totally fine. So as our point group grows, we gradually remove the frozen pins, the stop pins, and then we're just using a rest blend, and we do this on each substep. You can do this on each frame, which is like single frames the default, so I try to do it in the first frame. That will most likely crash Houdini in this case, so make sure to put it on each frame or each substep. As we're doing 4 substeps, it tries to do like 4 times per frame basically. So I put it on each substep because I think it looks a little bit cleaner. even than each frame. Each frame also totally works. So if you have your Vellum solver on one substep, you can just do each frame. From there, we only need to set what to pull from. And again, our out bend that we had here, or actually blend might not be too stupid as I had it before. So I'm going back to this because the operation is actually called blending. So I'm pulling this. Again, it has exactly the same points as you can see here, so it needs to have the same topo, otherwise it won't work. And we go in here and we just set it as our source. So source is sub, and the sub is our blend. And that's all we need to do in the Vellum solver. Not much more to do here. From there, you can just reset the simulation just to make sure and hit simulate. And I will see you in a bit because my CPU is not the fastest anymore, so it takes a little bit of time. But you can already see here it starts curling. Let me try to move the camera while it's doing this. Yeah, that's actually not too slow, I would say. But I will leave it running and I will be back in a second. And you can see I'm already encountering a little bit of an issue here. They just fall down. And this is because I don't have a ground plane in my simulation right now. I had it before, but when we do the curl, we don't need a ground. But if you want to try it this way, you can just add the ground position and offset it by 0.02 basically, so it's not colliding with it immediately. And if I play now, they should curl up perfectly fine on a straight line. Yeah, I will let it simulate and see you back in a second. All right, and we can see we have a nice little curl here. I still have this pop here in the middle that we could get rid of with a few tricks, but you can see that it's sort of the tension in the piece because it's trying really hard to get to this bend position, like our bend position that we have here at the top, with each frame. So that creates a lot of tension in all the other points that are still frozen. So as soon as they are like released, you can see they are released here to get this rippling, which you could get rid of with like some better mask and some better attribute blending and whatnot. But in this case, I won't bother and just keep it like it is. So this is already pretty cool. You could do this on straight things or wrap it around other things, or wrap it on an object that has UVs and do some fancy UV blending stuff like you would do on let's say a knitting project or in my knitting solver. You could do the same with this type of curling, and actually thinking about it, I might actually implement it that way into probably easy peel, I guess. So stay tuned for that. Yeah, so let's keep on going. So this is basically, I'm just using the Vellum pack here to do a file cache, and then I'm packing it again and using a Vellum post process to give it a little bit of thickness. But what I cached here is the cold version. So to cold this, as I said, you could wrap this around like a circle. And I use the spiral here because it gives you some nice attributes to start with. So I just set it to a certain radius that really depends on how big your grid is at the top. I will show later. I set the turns to 0 basically, which makes it into a circle, and I set the rotation to 90, so it's facing, or it's in the y-axis. From there we use a path deform, and what the path deform is doing is wrapping whatever geometry you're putting in here around whatever geometry you're putting into a second stream. So the forward direction is x in this case, as our geometry is lying on x. From there we can use the map and deform to offset our curve position, so you can rotate your piece around it, and I did that as well. Like if you go too far, you actually sort of unwrap it So keep it somewhere in between. I don't know what I had, like 0.4 something. And you can obviously do a few more things like taper and rotate and whatnot. But that's literally all you have to set. And coming back to this radius on the spiral node here is if I... let's make it a little bit bigger. So you can see at some point it like rips apart. So you have to carefully find the matching point. And don't make it touch itself. Leave a little gap, because otherwise they will be stuck in the Vellum solver. They will be fused together in the first frame. So this works pretty well. Let me open it a little bit up again, because I want this seam to be at the top. So for that we can use this offset I was mentioning before here, and we can pivot a little bit. And this is fine. This is top enough for me. So I'll fuse it back together, not fully, like so I can see a little gap here. And from there, remember, we just added a ground plane, remove this, and don't worry, they don't fall down immediately, because if you remember correctly, we stopped all these points, so they only get activated on the sides. So if I start the simulation now, they will start opening again, which is very nice. And if you're wondering why the heck do they now work in like a circle, although all like bent, like initial bend here is done on a straight line. This is because we will still keep like the point count and the typography, so it's not like a topology, sorry, not typography. And therefore the points still understand this movement and still understand this opening that we set initially here, and they don't really care about like the path deform that happened to them before. So yeah, technically you could wrap it around anything basically. So if I go through here, you can see it unpeels now, and we have a little touching here, which is unfortunate because these are actually different pieces. You might want to offset it a little bit, or give the Vellum solver a little bit more substeps, because they shouldn't be connected really. But that just means like tinkering or fiddling around with the settings a little bit. And if you want to have multiple layers, you just do exactly the same as you did with the first like geometry preparation, and offset it a little bit to like in the y-axis. I did minus 0.2, 0.8 and so on. I said you could do like equal spacing or different spacing, doesn't really matter. But now we have like multiple of those, and the for each and everything still works. So you can add as many layers as you want. So you can see slight offsets here. They all cut a little bit differently, and they also all, like the bending still works totally fine with all the layers as well. Just make sure you catch them all basically. And path deform also works. Again, make sure you still have a little gap in here. Yes, we do. And from there we can throw in the Vellum solver and hit play, and maybe due to different geometry now we might actually resolve this like sticking issue of this one piece already, and you don't have to tinker around with that anymore. Yeah, and I think it looks fine. I would leave this running. Well, I don't have to leave this running actually, because I cached a version of this already. So I can go in here and you can see now it like sort of unpeels these pieces, which is very nice. Very nice to see. Super cool. You could put this part here right in here as well to control when each layer peels. Because now they basically all do it at the same time. which in this case though still looks fine because they sort of stop each other, like the first layer holds down the second layer and so on. So it still looks kind of natural. But if you wanted to control it manually, you could put this piece in here as well, and do like each stream with like its own pinning animation. Yeah, and from there I just use the Vellum post process to just blur it a little and give it a little subdivision, like one more, just to make it a little bit smoother for rendering. I didn't even give it thickness because that sort of breaks the normals a little bit, and it was just easier to render it this way. And from there I literally just removed attributes, create new normals, and actually blurred the normals a little bit, because let me try if I can make this visible. So if I don't do this, you can see we have this little ugly like bumps going on here, and if I blur it, they're still there, but it's a little bit less, so it looks a little bit nicer in render. And I'm using connectivity again here just to create a new class attribute because I'm using this in shading. And from there I just go to stage and import it and apply shaders and some lights, and nothing fancy here. As you can see, it's like the most basic render you can imagine. But as I said, I want to continue this series and like push this a little bit further, and some particles and some hairs and stuff like that, and make it look a little bit nicer as that. But for now I just put like a random wood veneer with a little bit of a color difference based on the class attribute. So yeah, nothing too fancy. If you want to see how I set up the shaders, let me know in the comments, and I can do like an extra for this one. Yeah, otherwise stay tuned, because I will probably put that into Easy Peel, so it's a bit easier to use, you know, you don't have to remember all of the stuff. And yeah, there will probably be a second part as well, because I want to develop this a little further and push it a little more towards the reference I saw, which I think still looks very, very nice, although it's from Host. I can't remember the year. Well, it's actually quite old already, and it looks incredible. So yeah, I want to push it more towards that direction, and yeah, I want to keep you guys along. So make sure you subscribe. You can find this scene file. I will upload the scene file to my Patreon, so you can grab it from there, and then hopefully see you in the next one.